Welcome everyone. Thank you all for making the webinar. My name is Dan Swick. I am with the Delta Institute, and this is the second installation of our Transportation and Environment webinar series. We'll just take a quick second to go over the technology here for everyone. If you take a look at, usually on the right side of your screen, you'll see a number of controls for the webinar. Probably most important to today's presentation will be the question and answer box and the chat box. If you have any questions throughout the presentation, please feel free to type them into the question box and hit send. We will be doing this presentation in two parts. We'll be taking questions after each section. So feel free to enter your questions as you think of them, and we will ask them of our presenter at the end of each section. Again, this is the second installation of our 2012 webinar series, the Green Infrastructure Vision 2.0 preview. And before we get started on that, just a little background on this program. The Transportation and Environmental Collaboration Program began as a project of the Chicago Wilderness Sustainability Team, and its mission is to facilitate understanding and agreement between transportation professionals and environmental advocates. The project began in 2008, and in its first 2 years was focused on engaging stakeholders through a series of educational workshops for both transportation professionals and environmental advocates. In 2010 and 2011, we worked with local partners in McHenry County, Illinois, and Northwest Indiana to map and prioritize natural resources in those areas. On your screen now is just a little overview of our partners in those areas. On the left side of the oval are our partners from Northwest Indiana, Save the Dunes, and the Shirley Hines Land Trust. And on the right side are our partners from McHenry County, Illinois. And that's the Land Conservancy of McHenry County and the Environmental Defenders of McHenry County. We would also like to recognize our funders for this program, the Gaylord and Dorothy Donnelly Foundation. So during the resource mapping and consensus building portion of this program, we held a series of meetings to identify and map priority resources in our target areas, and then go through a consensus-based refinement process. And then finally, producing those map documents and making sure that our local stakeholders are equipped to utilize those resources. And here's a quick example of one of our map products. This is the Gary Airport in Northwest Indiana. And the actual site is outlined in a dashed line, and then surrounding it you can see the product of our work with local stakeholders. The green, yellow, and red colors are the result of the priority resource mapping process. And in this particular process, we underwent quite an extensive ground truthing exercise with local stakeholders who have years of experience working in the natural resources of this area. And they actually ended up editing some of our map products from the GIS process and creating a very well-informed map product. Then you can also see in green, or excuse me, in teal and pink, some of the planned transportation projects in that area. And that brings us to 2011 and 2012, where we're continuing engagement with our local partners, continuing to refine our map products, and hosting this series of educational webinars for stakeholders throughout the region. So without further ado, I will introduce our presenter for today. Mr. Will Allen is the Director of Strategic Conservation for the Conservation Fund. With over 15 years of experience in green infrastructure planning, he is responsible for project design, management and delivery of customized conservation services for partners that advance the Conservation Fund's dual charter of environmental protection and economic development. His experience includes green infrastructure network design, GIS analysis and advanced cartography, design of decision support framework, and rapid assessment of natural resources. Mr. Allen and the Fund team are now undertaking a comprehensive 13-county green infrastructure plan for the Greater Houston region and updating the Chicago Wilderness Green Infrastructure Vision GIS layer originally developed in 2004. Mr. Allen is the co-editor-in-chief and managing editor of the Journal of Conservation Planning and co-founding board member of the Society for Conservation GIS. He holds a Bachelor of Arts degree in Urban Studies from Stanford University and a Master's in Regional Planning from the University of North Carolina. And before we jump into Will's presentation, I just want to ask a couple of poll questions of the audience to get a feel for how familiar everyone is with some of the subject matter. So the first poll is going to pop up in just a second, and you can select your answer from the screen. So the poll should be up on your screen, so go ahead and choose your answer. And once the questions are in, we will display them on the screen. Okay, it looks like just about everybody has voted. Okay. So here's just a quick breakdown of everyone's experience with the 2004 Green Infrastructure Vision. It looks like most respondents are either very familiar or haven't heard of it at all. So we have a pretty good range of experience here. And one more poll question before I hand the controls over to Will. So have you taken part in any of the GIV 2.0 webinars to date? Okay, it looks like just about everyone is in. Okay, so it looks like most folks have not participated, so this will be a great chance for those people to learn a bit about the process and what to expect coming forward. So with that, I will hand the controls over to Will.
All right, thanks, Dan. Once I see that my screen is up on your screen, I will get going here. All right. All right, we should be underway. Thanks again, Dan. Again, this is Will Allen with the Conservation Fund, based in Chapel Hill, North Carolina, but have spent a lot of time at my desk today and many days this year working on the refinement of the Chicago Wilderness Green Infrastructure Vision. Since there were some folks who had not heard of it before, I'll briefly tell you that back in 2004, Chicago Wilderness developed a data layer of resource protection areas. And they developed it through a charrette-based process with stakeholders who were familiar with the local resources. And so you'll see some maps of that in a moment. And what they wanted to do was update that using more automated and science-based criteria to refine the boundaries and the edges of the Green Infrastructure Vision so that it could be more actionable at the local, municipal, and county levels. So we began this project thanks to a contract from the Chicago Metropolitan Agency of Planning with funding from the Illinois Department of Transportation. I've been working on this project since July of 2011, and we'll be wrapping up this first go-around here on June 30th. And we're literally in the middle of wrapping up the next iteration that's going to go out for a final review as part of this project. As part of our project team, we have the Conservation Fund. We also have Applied Ecological Services. And the Chicago Wilderness Green Infrastructure Task Force has been our primary reviewing entity. But we did have a couple of public workshops, which I understand a few of you have attended. And those were in October of 2011 and March of 2012. Hold on one second while my screen decides to freeze here. One moment. Go here. All right. All right. Trying to see why. There we go. All right. So why is the term green infrastructure used? It's basically used because the notion of infrastructure is of the foundations of a community in terms of growth and development. And so a lot of these important resource features, such as woodlands and wetlands, streams and lakes and prairies, are critical elements of green infrastructure. And because of that, they should be considered the way other types of gray infrastructure are utilized and funded. And so there is an interest in having those infrastructure needs funded up front and thought of as an essential component of a community's infrastructure. I apologize for that. Are you able to hear me, Dan? Are you able to hear me, Dan? Dan, are you able to hear me now? Are you able to hear me now, Dan? Dan, are you able to hear me now?
Yes, you're back now.
Okay, I apologize. The phone just went out. I just called back in. Let's keep moving. My apologies. We'll just chalk it up to gremlins. So the green infrastructure approach that we're using for the refinement of the Chicago Wilderness Vision 2.0 is intended to help with these transportation and ecological issues in terms of where are the best places to conserve land, where to permit development, where to build roads and utilities, and also where to select mitigation projects. So as Dan mentioned before, they've done a couple of pilot projects in Northwest Indiana and McHenry County. And in areas where they have not done that local collaborative process, this is one of the, I think, sets of information that will be very useful as you're moving along with those types of processes. Continue to have issues with the slides, so my apologies. All right, I'm going to navigate that out of PowerPoint show mode. You should be able to see on the screen a slide that talks about the benefits of green infrastructure. And the foundation for the development of the Green Infrastructure Vision Network is to have a set of information that helps answer some of these important questions in terms of identifying areas that minimize wildlife habitat fragmentation, provide interior habitat for critical wildlife, and then also have it be a framework that can lead to a more resilient community, particularly in relation to climate change. And in particular in the Chicago region, it is very helpful as a framework for habitat restoration and enhancement. On the right-hand side of the slides, you'll see a list of ecosystem services that are provided by green infrastructure, including clean air and water supply. The approach that we utilize is the green infrastructure approach. And this is the technical definition on the left-hand side that talks about having a strategically planned and managed network of natural lands. Green infrastructure can be applied at multiple scales. And in this project, we're actually, for Chicago Wilderness, looking at multiple scales at the same time. So we have kind of the anchors of the network at a regional scale related to core areas, which I'll talk about more in a minute. Then all the way down to a site scale where we're looking at things like urban forestry and stormwater management and low impact development techniques such as green roofs. This is an example of the refinement of the green infrastructure vision. The map on the left is the original 2004 Chicago Wilderness Green Infrastructure Vision. And the one on the right is the refined version that we're in the middle of working on right now, actually. This is an illustration if you zoom in on a particular location in McHenry County. On the left-hand side, it shows the original Green Infrastructure Vision 1.0 and an inventory of protected lands. The middle slide shows that information plus information from the new refined data. Those different colors represent different types of resource features. And on the right-hand side, that map represents not only those resource features, but then also something that we've been calling in this version complexes. These complexes are related to some data we obtained that had information on pre-settlement vegetation conditions. So we had information on where there was, when the public land survey system began, information on where there was forest, wetlands, prairies, and savannas throughout the Chicago Wilderness region in Illinois. So as part of this process to refine the Green Infrastructure Vision, this is the process that we've gone through. Not actually this linear, but it's helpful to break these into somewhat sequential parts. And we've been going through this again since July and are now finally in the home stretch here of finishing up numbers 5 and 6 there. And so we'll take a look at that in a moment. The goals and objectives was an easy one for this project because we were tasked with basically developing a data product that maintained the goals that were outlined in the 2004 Chicago Wilderness Green Infrastructure Plan. So they wanted this visionary regional scale map that looked at existing infrastructure, but then also looked for opportunities for expansion, restoration, and connection. and to come up with this more spatially explicit and scientifically defensible methodology. And as I said, bring to life the biodiversity recovery plan, which means some of the science-based criteria used in the refinement is based on essentially the requirements of important elements of biodiversity. And with all of that, it also therefore has an opportunity to help inform decision-making as it relates to development and conservation. Few ways that it specifically addresses the plan strategies outlined in the Chicago Wilderness 2004 data product. The focus is on the development of these large blocks of unfragmented landscapes and making sure that we identify those kind of best of the best locations. And then also, understand that there are still kind of small, important pieces that are part of the network, and that there is a complex kind of intermixing of different types of landscapes that may constitute a larger block where the whole is greater than the sum of its parts. Some additional objectives that are met by the new data product for the 2004 plan relate to trying to create functional connections that link together existing high-value areas that are the most suitable locations for restoration. And also that there should be an integration between areas that are already protected and therefore activities that can happen on those properties, and looking at adjacent properties. But then also, since most land in the region is going to remain in private ownership, identifying opportunities for conservation and restoration while land remains in private ownership. One of the tricks in trying to lump and split the different resource features within the region is trying to figure out how to break it up for mapping purposes. We follow an approach of developing these kind of landscape types, and it gives us a rationale for how to kind of organize the network. The trick here, as this figure illustrates, is that really the landscape is, for the most part, on a continuum. And the continuum is somewhat of a function of the level of tree canopy. Wetlands obviously can occur in all of this whole continuum here. But as it relates to prairie, savanna, woodlands, and forest, all of those are kind of, there's somewhat of an arbitrary break between some of those features. And so we've done our best to figure out what's a way to map and represent these features, but then provide flexibility for how people could make decisions on conservation and restoration opportunities within this continuum. In addition to those, there are also landscape types related to wetlands, streams, and lakes, and elements of regional recreation and urban scale green infrastructure. And so we also have identified and mapped those based on specific criteria that are being utilized in the refinement. On recreation, our design philosophy there is the notion that protected lands are kind of this pearl on the necklace, and that they are linked via a variety of local, regional, and municipal trail systems. So we have some mapping products related to that, and they integrate with the ecological elements as well. We went through a significant data development and quality assessment process and evaluated all the existing data that's available within the region. And as we finalized the report, a more comprehensive list of what was used and what was considered and not used is going to be part of the final report. But in general, the feedback we got was where you have best available data, go ahead and use it, rather than use the lowest common denominator in order to delineate things. So for example, on wetlands, we had seamless data using a national land cover data set for wetlands, but we had county wetland inventories that were more updated and more detailed. So we stitched those together and then filled in with other data sources in order to create the seamless product, understanding that there might be some issues across lines. But for the most part, we didn't have a lot of difficulty piecing something together that encompassed the best available data. So the design philosophy that is being used is this green infrastructure network design, where we have core areas that really serve as the nucleus of the network, some hubs, which are really aggregations of those core areas, and then these functional connections called corridors. And you'll see some of that in a moment. A few things just to highlight that are a little bit different from ones that we've done previously is we have used a brand new tool. It's called the terrestrial movement analysis. And for those of you who are familiar with GIS, this is a tool that's built inside the ArcGIS model builder to create those functional connections. There were other earlier generation ways to connect corridors, but this is relatively new and we found to be more robust than some of the other tools that are out there. The other major thing is that in addition to just knowing kind of it is where it is in terms of the resources, we really did put a significant focus on the restoration side of things, looking at the pre-settlement vegetation, hydric soils, trying to figure out where wetlands might have used to be, even if they weren't mapped as wetlands, and tried to create some systems. And Chicago Wilderness Wetlands Task Force data actually is used pretty significantly within the project. The other thing is we tried to design things to set up future work on trying to quantify ecosystem services. So by breaking them out by landscape type, it's a lot easier to then quantify the ecosystem service benefits of particular landscape types down the road. So that's why we did break out the landscape types rather than just have everything kind of end up in one single layer type of network. So there's a lot of data sets that are listed on this slide you currently see here. And these are the layers that will eventually be available via a couple of ways that will be the official Green Infrastructure Vision 2.0 network. Currently, the 2.0 network is going to be available for the 7-county Chicago Metropolitan Agency for Planning area. We're going to embark over the summer on a version 2.1 that would basically develop these same data layers that are listed here, and but apply it to the remainder of the Chicago Wilderness region, which is some additional areas in Illinois, southeastern Wisconsin, and northwestern Indiana. So this list is a set of data sets that will be available that can be overlaid on within a GIS system to overlay with additional information that you may have locally. There'll be more information on that as we finalize the report. But basically, the data sets here are divided into what I would say is 4 different categories. We've got specific landscape features and broken up into the 4 landscape types of woodlands. We've kind of lumped prairies, savannas, and grasslands together, wetlands, and streams and lakes. We also have functional connections, which are those corridors that I was telling you about, and then a variety of restoration building blocks. And so there's some pre-settlement data that's listed in there. The prairie grassland corridors are in there too, because those are all, there's no existing really prairie in there. So those would all be restoration projects. In addition, there are some areas that are either fell below an acreage or a value threshold that we had set in the criteria, but we didn't want to lose, based on the feedback from the folks who've been involved in the project. They didn't want to lose those important features because they could be built upon from a restoration perspective. So that's what the forest sites and wetland sites data sets are that are listed there. And then even though we have everything split out, there was an interest in having all of a lot of these data lumped together. And so we have an ecological network data, which is a subset mostly of the items that are in the landscape features and functional connections above. And then we merged all of the protected lands into one big data set to make them easier to deal with. And then there is a composite layer, and that composite layer is basically the protected lands plus the ecological network. And that is most akin to the Green Infrastructure Vision 1.0 data product that was developed. The other thing that we're able to do with this model is characterize the network in different ways. And we had a workshop on March 20th where we went into a lot of different ways that the data could be used. I'll just illustrate a couple of them here. One is related to really identifying suitable conservation locations for woodlands. And so you can actually develop models, quantitative models, that identify important places where woodlands may be suitable for some form of protection, whether that be stewardship by a private landowner or via a public entity. The protocol reference layer that you see there, that references a specific layer outlined in our methodology, and I'll just briefly show you what that looks like right now. But there's a detailed step-by-step methodology for developing these layers. And so you can kind of see here we have some very specific recipe type steps that will be in the final report, and they reference specific layer numbers there. And so that's just what those cryptic layer numbers mean in there. And so we're right in the middle of kind of working on developing what these models would look like for these, and those will be available in the next version of the Green Infrastructure Vision. So in addition to doing conservation suitability models, you can also do restoration suitability models. And this is just an example of forest, but this time on the restoration side. So there might be different ways to weight the various models. And then not only can you do that for woodlands, but you can also do it for the different elements of the landscape together and weight these in different ways to try and identify gaps in the protected network as well. So in addition to those very basic models, there's been an array of different potential applications identified through the Green Infrastructure Vision 2.0 process. And this is just a list of those that have been identified by local partners who have been participating in the process, where you can mix and match different elements of the network to try and identify these opportunities. In addition, once you've kind of identified some locations, there's a variety of different ways to implement the vision. And that's not, other than us describing some of those potential applications, the actual implementation itself is not scoped in the current project. But the idea is that the Chicago Wilderness Partners and the Green Infrastructure Task Force would identify opportunities to take full advantage of implementing the vision through a variety of different ways to implement things, through perhaps USDA cost share programs, other financing programs, through mitigation programs, and private landowners. So the map here that you saw at the beginning and now at the end, this is that composite map that includes all of the current protected lands and then also elements of the ecological network. But we are in the middle this week of updating this map, so it might look slightly different on the final. Here below is or to the left there is a list of the primary points of contact, which include our grant manager, Jesse, and then also the Green Infrastructure Task Force co-chairs and myself as points of contact. So, so that's it for that, but I did want to go ahead and show you, since we're in the middle of working on this project, I was going to just show you what some of these maps kind of look like. And these were literally made this morning, so you will be some of the first to see these, although our Green Infrastructure Task Force has seen different versions of some of these before. We'll just try and zoom in a little bit. It's easiest to do Lake and McHenry County just because the legend is up there on the map. But what the map shows is a core woodlands and forest layer that's identified as really kind of the best of the best. Some of the woodland and forest sites, which are wooded sites that are smaller, have an acreage cutoff, but are still potentially valuable. The pre-settlement complexes is on this map, and then there's this functional connectivity, which are these connections. And then this map also has the protected lands drawn underneath, so you can see where some of those are. So I'll just kind of show you, zooming in a little bit on McHenry and Lake, what that thing looks like. So this is kind of in here a large core forest complex in here, and then some specific opportunities for forest restoration amidst these pre-settlement areas. So that's the woodlands information. The streams and lakes, I'll pull that up too. We had to use brightly colored things for this one in order to have things be distinguishable. But the darkest blue is this core streams and lakes, kind of the best of the best. We also looked at the stream buffers and areas that were undeveloped along those, and then also undeveloped freshwater systems, which include things like well protection areas and floodplains. And then other elements of the freshwater systems and the stream buffer that were actually in some sort of urban land cover, and so therefore those were potential restoration opportunities. So here I'm going to kind of go just briefly into an area that's kind of a mix of the multiple counties, so that you can see areas like this little piece in here where there's a relatively intact stream buffer through the protected land, but outside of that are heavily urbanized. So you can kind of get a sense of that from that map. The other one I'll show is, let's do the prairie stuff. There's a lot going on this one too, but we split out the prairies, the savannas, and then something that we're calling potential grassland blocks. These are large areas that are showing up either from a state report of landscapes of ecological importance or large blocks of grassland and herbaceous land cover put together. There's also the pre-settlement data for both prairie and grasslands and savannas, some different functional connections as well. Some of those functional connections go through some pre-settlement forests, so we're actually masking that out using the pre-settlement forest. So you can see areas that are potential prairie corridors that are not pre-settlement forest conditions. So you can kind of get a sense of that. The different ramps, sort of the pink to purple, that's the darker areas there actually are better functional connections based on the modeling results that we've looked at. The prairie and savanna was kind of tricky because normally we would set some size thresholds as cutoffs, but because it's so fragmented, we waived all the minimum sizes for those. So if it was prairie and savanna and it was designated as such, then that was in, and it became part of the core data set. Last one I'll show is just a regional recreation one here. This was a CMAP regional trail data that was kind of the backbone of this, but you get a sense of a little bit of the pearls on the necklace idea, where a lot of these trails are going through and connecting the protected land. So that purple color is actually lands that are, or trails that have been, they're either on the ground or they're programmed to be on the ground. And the dashed ones are proposed. And so this gives you a visual sense of where maybe some of the more important gaps are to fill in terms of trying to create that true interconnected infrastructure network. So that's kind of the fast overview of this product. And again, there's going to be this will be out on the street probably in the July timeframe in a variety of formats, including GIS layers, possibly a map service, and then some of the hardcore GIS people are going to get all the models also that we are using to automate the development process. So I'll go ahead and stop there and take questions.
All right, thanks, Will. Looks like we have a couple questions in the question box. So the first one is, does GIV 2.0 include coverage in Northwest Indiana? And if so, how far into Northwest Indiana does it extend?
The Northwest Indiana will be in the 2.1 version. That 2.1 version will be done by November. We have had one meeting with the Northwest Indiana folks on the phone, and the plan is that when we cross the line, there's some data. They have some environmental corridors data there that is unique to their area, and so part of the exercise there is to figure out how to best stitch that information into what's been done for the 7-county area. So that's stay tuned for that one.
Great, thanks. And the second question was actually a general question about the webinar itself. And I'll just answer that question. It was whether we could put some of the initial intro slides up at the end of the webinar. We will be getting all of this information and a recording up on the Delta Institute website within the next week or so. So you'll be able to go onto the website and get those there. So I think that's it, unless anyone has any questions they'd like to enter in the next 30 seconds or so. I think, Will, you can go on to your second presentation.
Okay, great. I will introduce the second presentation by saying that we've done these types of green infrastructure mapping exercises in other geographies. And one of the key geographies that we have done green infrastructure work in is in Maryland. And Maryland was actually the first place that we really got to experiment very much with integrating the green and the gray infrastructure planning directly, of taking the green infrastructure mapping and looking specifically at transportation improvement projects and looking not just at potential mitigation sites, but then also environmental stewardship. The Maryland State Highway Administration not only want to do the compensatory mitigation work for a particular transportation improvement project, but wanted to go above and beyond mitigation and a concept that they called environmental stewardship. And so we did a detailed network design for a 4-watershed region in Maryland to help them develop what those environmental stewardship projects should be. So this presentation is simply kind of showing an application of green infrastructure in this gray infrastructure planning context. And now that there is a GIV 2.0 and eventually 2.1, this is the type of application that could then be utilized within the Chicago region. So we tend to call this approach applying green infrastructure networks in a gray infrastructure context. We call that strategic mitigation. And we think there's a lot of benefits to this approach. Aside from it being kind of regional and holistic in nature, having that framework for conservation and restoration really helps identify some of the best project opportunities, and there's an opportunity to really strategically use mitigation dollars to make sure you're creating projects that have multiple benefits. And I think obviously from the gray infrastructure side, one of the most important things is just having predictability and certainty moving forward through this kind of process. The maps that are actually on this slide are related to Kansas City. Kansas City, we have a small project with them right now to identify a framework for mitigation for some of their transportation projects, and we're using some of the philosophical approach of this in that area as well. So there's really a we like to call it a four-step process for doing this strategic mitigation work. Got to identify the mitigation needs and opportunities, develop this green infrastructure network design, develop what your mitigation project selection criteria would be, and then you can optimize that project portfolio based upon the benefits of projects and then also your cost constraints. So for this one, we partnered with the State Highway Administration in Maryland, the Maryland Department of Natural Resources, and the U.S. Fish and Wildlife Service. This is an area near Waldorf, Maryland, that's just southeast of the District of Columbia. For those of you who are DC folks, where I've got my little cursor right now, that's the Woodrow Wilson Bridge right there. So it's on the approach into National Ronald Reagan Airport there. There's a growing bedroom community for the DC area, and this US 301 road was in need of an upgrade through here. They were looking at both a upgrade option on the existing alignment, an eastern bypass, and a western bypass. So part of this project was there would be variable impacts based on what alignments were taken, and therefore different packages of environmental stewardship that would make the most sense. The other tricky thing in this location is there's a globally significant swamp over here, Zakai Swamp on the east side in that watershed, and then a global or nationally significant anadromous fish spawning area along Mattawoman Creek here. So, so some tricky environmental and engineering issues as it relates to avoidance and minimization. So since you have a sense of how the green infrastructure gets developed, kind of cut to the chase here and said that you know, we went through a similar mapping exercise through green infrastructure network design and came up with these kind of core areas and rank them based on their ecological value. So you can kind of see that in that context there. And we used similar landscape types that we did in Chicago in terms of forests, wetlands, and the aquatic systems was their version of the streams and lakes information, and there wasn't a comparable prairie grassland data in this geography. In addition to having the network design, we also went ahead and did an overall ecological score, and you can see that slide on the right. That is akin to when I was talking about with Chicago Wilderness, the characterization models that we're going to be running. So if we had run a composite ecological value on the GIV 2.0, it might look something like the one on the right-hand side that was done for that. So what this allowed us to do is then look at the parcel level within these watersheds and really be able to figure out what are the highest ecological value properties that might be candidates for environmental stewardship. Part of the process, however, was identifying specifically through stakeholder feedback what were the most important resources to do environmental stewardship and mitigation investments. And we had some facilitated workshops as part of this, which sounded similar to some of the ones the Delta Institute was facilitating in Northwest Indiana and in McHenry County. We asked them in these meetings, most interestingly, what kinds of activities they thought were the most important. And in the polling that we did for that project, 60%, they wanted 60% of the funding, the environmental stewardship funding, actually to go to conservation and preservation under the philosophy that it would be better to use the money to protect existing pristine resources rather than spending money on the more expensive restoration components. In this geography, that was something that was possible, given there was, as you can see from the map, relatively limited fragmentation of some of the key resources. green infrastructure network is there, and then all of these dots, they actually went through a dot mapping exercise of identifying specific environmental stewardship needs of different types through that became then candidate mitigation and environmental stewardship sites. This was followed up by detailed field investigations in a few strategic locations related to both conservation and restoration opportunities. So this map just illustrates a few different places that were identified for further work and field protocols were developed as part of this process to help assess the relative value of wetland and streamside and forest systems. So basically the GIS could get part of the way there doing the quantitative work, but ultimately you had to go on the ground in some key sites and then apply a ecological field protocol that could then quantitatively assess the value of sites at a site scale that the GIS modeling was not able to do. Once there was an assessment of the environmental or ecological benefits of particular projects, we utilized and designed some optimization decision support tools to help with project selection. Basically, optimization is a technique to try and basically get you the biggest bang for your buck. It's probably the easiest way to say that. That if you have a fixed budget constraint, you want to try and maximize your benefits based on your budget. And so the graph on the right side actually illustrates this better than me talking about it. Most folks select projects where they'll say, this is the highest ranking project, I'm going to pick that one, and however much that one costs. And then I'm going to pick the second one, the highest ranking, regardless of cost, and go down. And then eventually you exhaust your budget that way. That can be very inefficient from a selection standpoint. This kind of pink line is an example of where that happens. So for instance, you go through and pick your top ranked spots. If you could spend about 75% of your money and only be getting 40% of the total acreage or benefits associated with that. So, you know, at the bottom graph, if you buy nothing, you get nothing. If you buy everything, you get everything. But it's this area in between. And so if you use optimization, you can get higher aggregate benefits at the same cost. So by way of illustration, on this graph, if you take about 40% of your budget doing a rank-based system, you only get about a little over 20% of the benefits. But up here, for the same price, if you selected differently, you could have 60% of the total aggregate benefits. So it's really the spread between the two curves shows you the marginal benefit of selecting projects based on optimization rather than rank-based. There's a significant pool of peer-reviewed literature on this project. So what it really does is it offers the opportunity to get good value, good buys that are available. And it allows you to really stretch your dollars quite well. So the goal is specifically to seek the aggregate benefits rather than just go on a project-by-project basis. And so consistently, project after project, we've done probably a half dozen of these at least, with another half dozen coming, that this consistently is very effective. Another way to illustrate it, just by way of example, is if you had a fixed amount of money that you were going to spend on wine, would you rather have 3 bottles of that $80 top-rated bottle of wine, or would you rather have 12 bottles of $20 wine? So it's a similar concept here. So here's that graph again that I already illustrated. The tool itself, actually, the one I'm showing here is an Excel-based tool, but we now also have a web-based tool that is available. And basically, in order to use this tool, you need to, the inputs into the model are essentially the projects themselves, the benefits in terms of scoring them, the costs of a particular project, and then the constraints, such as the budget scenarios. So this is an illustration of the Maryland example, where we set an optimization scenario where we said you can only do 30 projects and kind of constrained it based on that, based on the capacity of working with partners to do those projects. Under that scenario, if you took the 30 top ranked projects as opposed to trying to optimize, you'd be spending $3 million more and be getting less of the green infrastructure network as a result. That becomes even more dramatic if you actually reduce the constraint on the number of allowable projects. Then for the same price, you can do a significant amount of additional work. This has been applied probably most successfully by the Baltimore County Department of Environmental Protection and Resource Management. They have an agricultural easement program where they are trying to protect essentially 80,000 acres of agricultural land in Baltimore County, and they're at about, I think they're at about 50 to 55,000 currently. And they wanted to make sure that to get that last 25,000, they stretched their dollars as best they could. The program is kind of an annual application program. And so we were able to very easily track kind of how well they're doing. We built them some GIS models to do the benefit side of things and allow them to kind of weight different factors for that. And then using those benefits and then the cost, the easement cost, look at different project selection scenarios. We're waiting on the new data, but for at least the 2007-2009 period, which were the first 3 years that they implemented optimization, they were able to protect an additional 680 acres for a savings of $5.4 million based on had they gone through their old selection process of just doing rank-based selection. So based on how much it cost them to implement optimization relative to those savings, they have about a 60-to-1 return on investment thus far, and that doesn't include the last couple of years. There's a lot more information that's available about this Maryland project that's in some books and some peer-reviewed literature, so that's listed here as well. And that's all I've got for this one, and I'm happy to answer any questions on this one.
Great, thanks, Will. I'm not seeing any questions in the question box, so if anyone has anything they would like to ask, feel free to type that in there now. But otherwise, I think that's it, unless you have any other comments to add, Will.
No, other than I think I've mentioned that the timing of this is such that literally I was exporting maps out of ArcGIS this morning for the Chicago Wilderness, this 2.0 product. So you guys are really fortunate to be getting kind of a building the plane while we're flying it view of some of this information, particularly for those who haven't been involved in the previous workshops. I know that part of the Chicago Wilderness Outreach Plan is to get this information disseminated down to the municipal level. And some municipalities have been involved, but not everyone, and that was just kind of a limitation in this first round. But there's a high priority on doing additional outreach related to this to see how these tools can best be applied in a variety of conservation development decision-making contexts at the county level, municipal level, township level, and ultimately regionally, looking at Wisconsin, Indiana, and other parts of Illinois.
Great. So we did just get a question from a CMAP representative, and they ask, how soon could we use these layers for planning? He says, I see an immediate need for a couple of communities that they work in.
Yes. This is supposed to be out on the street by June 30th. I have, through Jesse Elam at CMAP, There's been some things kind of going on right now, and to the extent we have been able to provide information that's been draft or interim to help with those processes, we have been doing that. So what I would suggest is Jesse has kind of a running list of concurrent projects that could benefit from these products. And I would suggest to that person to definitely talk to Jesse Elam at CMAP specifically to facilitate getting that information to them at the earliest possible convenience.
Okay, great. All right, well, that looks like it's it. So thank you very much, Will, for the fantastic presentation, and thanks to everyone for attending. Just wanted to give a quick PSA that the next webinar in our series will be coming up on June 20th, and I'm just going to put that up on the screen here. So mark your calendars if you're interested in this topic and seeing or hearing firsthand from some of our great local partners in Northwest Indiana and McHenry County. So again, that webinar will be coming up on June 20th, so mark your calendars. Thanks again, everyone, and have a great day.